Welcome to FMA 0134 Mathematics 3. This video will be the last chapter of your Mathematics 3 partial derivative. Derivation. Okay, the topics covered here actually will be the first order partial derivation and the higher order partial derivation. Both also can use the chain rule. Okay, so now, as usual, what is the motivation that you need? We learn our partial derivative. So actually, basically, for the partial derivative means we are going to involve two different. In one function, we have two different variables. So, for example, here that is, if x1 and p1 are the demand price of the tea, x2 and the p2 are the demand and the price of the coffee, and the demand function are given as below. Calculate the two elasticity, demand, and so on. And then the second one will be like demand condition will be like that, and then you use the thing. Okay, so no need to worry, your question is not this complicated. So let us recall our ordinary derivative. Okay, if y is a function of x, then dy dx is the derivative, meaning that it's a gradient or the slope of the graph or the rate of a change with respect to x. Okay, that is only if your function is the function of x only, or you have a y only. But now for the function of two or more variables, function which have more than one variable arise very commonly. Simple example are formula for the area of a triangle. A equals to half BH. So B and H are two variables. So you have a base and the height. And on we have a formula for electrical resistor. We have R1, R2, and R3. So we have three different variables over here. So partial derivation is the derivative of a function of two variables and more, okay, and more, okay. So but over here we look at two variables first. Z equals to Fy, where we have two independent variable which are x and y, while Z is the dependent variable. Since Zfy is a function of two variables, if we want to differentiate, we have to decide whether we are differentiating respect to x or respect to y. We cannot do both together. So means that if we want to differentiate towards x, so you will keep your y as a constant. If you want to differentiate your y, you will keep your x as a constant. Okay, and then we use the symbol del instead of a d. Okay, so please don't use d, okay, it's a del. So, and introduce the partial derivation of a z, which, okay, so when we have a del z over del x, is written as a partial derivative of z, of, or it's not necessarily z, it can be f and so on, with respect to x means that differentiate with respect to x holding y as a constant. If you have a del z over del y, means that we are differentiate respect to y holding our x as a constant. So, and sometimes that is we are not using the del z over del x. Sometimes we just can use a z, and then the below has a small x, and then z the below has a small y. So that means you are differentiating towards y if you have a zy. Okay, so let us look at the first example of a function two variables. So we have a z in the form x and y. So if you want to find the del z over del x, okay, so means that over here, this is our z. Okay, this is our z, and we only have an x over here. The rest are the constant. So differentiate constant is 0, differentiate constant is 0. So del z over del x equals to y. And then the same thing happened to our del z over del y. So this one is a constant, this is a constant, both go to 0. And then we have a negative half y. So differentiate differentiate y actually is 1. So it's a negative half. Okay, so how about if we have some sort in we have an x1 which is not nonlinear, so nothing special. So what you need to do is you need to identify if you want to differentiate towards x. So we just like here, I highlighted x is here. So these two actually is a constant. So over here, differentiate x squared actually is 2x. Differentiate, okay, excuse me, 3xy, okay, and excuse me, over here there will be don't have no need to use product rule. The main reason is 3y over here actually is a constant. So differentiate 3yx actually is 3y, and then over here this one is a lot easier. The rest, okay, so this is my y, this is my y. So differentiate y, 3xy actually is 3x. Differentiate y actually is 1. The rest are the constant. And then how about if you have a ln x squared y? So same thing, you still need to identify where is your x. So differentiate ln actually is over, and then differentiate inside is 2x, and then this one differentiate, and then actually I think this one actually is a positive one. Okay, so that's all. Okay, then after that, if you have this one, okay, so please don't confuse with product rules. This is a partial derivation, so there will be no implicit. Normally you no need to use the product rule unless you have an x and x together. So x cos y. So this is my x, this is my x. So differentiate x, you get cos y. Differentiate ex is an ex. So the y is a constant. So this one, my y is here, my y is here. So differentiate cos y actually is negative sign y. So keep my x here. Then my y ex, so ex is a constant, so ex. So differentiate y actually is 1. Then the next one, okay, this one, some of you were just thinking, is it this one will be implicit, whatever. So the x is here only. Okay, the x is here. So differentiate sine actually is cos xy. So since this y is a constant, so you differentiate yx actually is y. So you have a y squared. Okay, this one, see this is a y, this is a y. So now this is the first time you see we use the product rule. So we use u equals to y. So u prime actually is 1. Then we have v equals to sine xy. So v prime actually is cos xy, and then this x is a constant, so this is x cos y. So we have a u v prime, so it's y x cos y, and then sine y. Okay, so this one is using the u v prime. This is a v u prime plus u v prime. Okay, then the next one over here. Okay, so this one is the you need to evaluate. Okay, the evaluation is always at the last. So when we have an x squared y squared plus z squared equals to 1. So because the question asking for del z over del y, so what we do is one way is the easier one is we rewrite. Okay, we rewrite everything in terms of z if it is possible. If not possible to rewrite, then we can use partial, we can use implicit. If not, then we try to write it in this way, and del z to del y. So this is only my y. So negative half. Okay, then differentiate the inside is 2y, and then this one they ask you to substitute 2 over 3 and 1 over 3. Okay, so you just substitute inside, then you will get your answer. Okay, so now if this one I have a del w, del x, del z, so same thing. The first thing is del w over del y. So you identify this is your y. So the rest will be constant. So differentiate sine actually is cos. Differentiate y actually is 1. So you will have this one. And then if you want to have a x, okay, so this one is don't have. Okay, so if you have a del w over del x, so that means this one is x, this one is a constant. Differentiate x actually is 1, so you have this one, and then this one is the same as the previous one. So this one you have a 3z at the outside. Okay, so this one we're going to cover during our class. Now we go for the second order partial derivation. Okay, second order means this we are going to do twice. Okay, so that means if you want to differentiate towards xy, so you have a zxx, zyy, z. Okay, now this one is a bit different, okay. When we have a del x, del y, when you write is y, okay, this one y, because we are differentiate towards y first, okay, we are going to differentiate towards y first, and then we are differentiate towards x. This one is differentiate towards x, then towards y. Why? Because when we have the way we are writing differentiation, first thing is del x, del y, okay. If you want to differentiate the second times, okay, so when you want to differentiate the second time towards this one, so when we combine this thing, it will become del square, del x, del y, okay. So means that this is the way how we write the second order. Okay, if you want to have a third order, if you want to differentiate this one towards z, so we differentiate this one towards z, so you are going to have a, this is 3 because 1 2 3, and then the z is over here. Okay, so and then the other way, generally del z, del x, del y, and del y, del x is always the same generally, but maybe there is one or two example that will be have a different name. Okay, and then when you have differentiating the word x and y on x, they call it as a mixed partial derivative. Okay, so now if this one, okay, if you want, they ask you to find all the first and second derivative order, means that you first thing you differentiate towards x first, then towards y, and then from here you do the second derivative for the x, so you're going to have a del square z, del x square. If you want to get this one, so you start from here. If you want to have the other one, del x, del y, so this one you coming here, this one is going here. Okay, so let us look at it. So the question here is z. Okay, when we have a z is this one. If you want to differentiate towards x, so this is my x, this is my x, the rest will become constant. So when you differentiating, so you have an x, 8x, and then this x is disappeared, negative y4. If you want to do the second time of towards x, so you start from here. Okay, so you start from here, differentiate. I only have an x over here, so I have an 8 here. So when I have a y, so I only need to identify this is my y. So I have a negative 32 xy cubed plus 35 y4. Okay, differentiate normally. The rest is a constant, becomes 0. Then you can differentiate second times towards y. So identify where is your y, then you differentiate normally. Now the mixed one is, okay, so means from the x I have, okay, I differentiate the second times towards y, so I will get this one. So I start from 8x minus 8y4, so I only have y here, so then negative 32 y3. And if I want to have start from a del y, I want to differentiate towards x, so I start from here, coming here, so this is my only x here, so it's negative 32 y3. So as I said just now, generally these two answers will be the same. But the thing is, you need to remember, if the question in the if the question in the exam or whatever asking for the del x over del y, you need to do according to the step. Means that you need to differentiate towards y first, then you differentiate towards x. Okay, although they are at the end they are the same answer, but the thing is you need to follow what is the requirement of the question. Then now we look at another example. Let z equals to sine xy. So they also same thing, ask you to find the first and second order partial derivative of z. Okay, so that means we are going to find del z, del x, del z, del y, del squared z, del x squared. Okay, so as usual, although if they ask you only for second order partial derivative, you also need to start from the first order. Okay, so as usual, we need to identified where is our x and where is our y, so the rest is kept as constant. So since x is here, so then the y is a constant, so differentiate sign actually is cosine, so xy copy back, and then differentiate x actually y. When y is a constant, you just keep your y outside, and then this one keep x and outside. Okay, if you from here, then we can do for our second derivative for both the do the second derivative, okay, for the towards x. So this one is only our x, so then we differentiate. Cos actually is negative sign, and then we have an y square. Then here is still the same, differentiate cos actually is negative sign, so sine xy, so negative x squared. Okay, so from here, if you want to differentiate to y, so what you need to do, then first thing we need to check, we have an y, this is our y, so that means they are a product rule. So as usual, you keep your u as a y, so u prime actually is 1. Then our v actually is cos xy, then our v prime is negative sine xy, and then this is y is our variable, so then we have an x as a constant, so u v prime, so this one is xy sine xy, and then this one is v u prime, so is cos xy. So you can do the same thing for the del z del x. As I said just now, both of them normally they will be having the same answer. Okay, so this one we will discuss during the class. Okay, now if this one actually sometimes you no need to worry, although it's an x, x, y, z, and so on, actually they are will be the same, you just do one by one only. Okay, and then this one is a special example. Okay, why I call name it as a special example, because if you look at the question, given z is f x squared plus y squared, they are okay. If you see that the previous one is let f comma y comma z equals to sine 3x and so on, but this one is very weird. It said that let z equals to f x squared plus y squared, where your f is an arbitrary function. Actually this thing, okay, actually maybe I don't know whether you will see it again or not. Normally they do it for the normalization, but I don't know why it is inclusive in one of examples in your chapter 7 in your module, so I also discuss it. So now find the del z del x and del z del z del y over here. So hence show that is x del z del y minus y del z del x equals to 0. So first thing, okay, the method is already fixed. The first step is always let your u equals to x squared plus y squared. So now this z is going to change it to become z equals to fu. Okay, then after that, then we know that by our chain rule, del z over del x actually is del z del u. Okay, this one is already become d. Okay, dz du multiplied du dx is no more del. Okay, it's this become d because when only one variable you use d. If you have two variable, it is using del. Okay, so now I repeat, although we are looking for del z del x, but because I already we use the substitution u equals to x squared plus y squared, we substitute our x squared plus y squared become u. Now it's become one variable. When this is one variable, we use d. If have a more than one variable, we use del. So that's why we have a dz du multiplied du dx. So now what is the du dx? Because I already let my u equals to x squared plus y squared, so my du dx actually I differentiate. This one is constant, so I have a 2x. So that's why my du dx actually is 2x. And do you know what is dz du? Okay, we don't know. We just keep as a dz du. Okay, so what happened to our del z del y? Same thing by using the chain rule. Dz du multiplied du dz. Then what is my du dx? Actually, this is my du dy. So it's 2y dz du. Okay, when they ask you to show just what you need to do, copy back the what is the left hand side? This is my left hand side. So del z del u, I just change it to become my dy. Okay, del z del x actually is del z del y actually is 2y. Dz du actually is d, dz du minus y 2x dz du. Okay, if you expand, actually this one equals to 0. Okay, so that's all for your chapter 7. You just maybe some of you will be a bit confused. This actually chapter 7 is very 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 easy. Means that when you want to differentiate towards x, the rest of the world will become constant. If you want to differentiate towards y, the only person you need to take care is only y. Okay, thank you.